Hi, we're going to look at Radians section 3 arc length today. Basically looking at how you can calculate arc lengths of circles or parts of circles using radians. I'll go quite quickly as always. Please just pause it if I'm going too fast. There's lots and lots of different example questions for you to try, so it's a matter of you pausing it, having a go at the question, and then I will go through any how the question works. So what you've seen before, if you wanted to work out the full perimeter, the circumference of a circle in degrees, you would just do 2 pi times the radius, so it'd be 2 pi r. Then if there was a particular section that you wanted to work out, like L in the diagram above, what you would need to do then is work out what proportion of the full circle your angle is. So it would be theta over 360 times 2 pi r. For radians, this time, instead of there being 360 degrees in a full circle, there are 2 pi radians in a full circle. So for radians, it would be theta over 2 pi times 2 pi r. So the 2 pi's would cancel, so you get this lovely neat formula that your arc length is just equal to r theta, when theta is your angle in radians. Okay, a couple of quick questions I've pinched from the textbook. If you would like to have a go at those, and then if you pause me now, and then I'll go through them in a second. Okay, a couple of points below that are worth noting. You only need to have your calculator in radians if you're doing a function of a circle. So if you're doing sine, cos, or tan, and you put the angle in radians, then your calculator would need to be in radians. If you were just working out arc length, because you're just doing your radius times your angle, then you don't need to have your calculator in radians. And subtended means opposite or extending beneath. So first one, we've got R is 5.2, we've got an angle of 0.8, so it's just r theta, which gives you 4.16 centimeters. Second one, this time they've done it the other way around. They've given you what the arc length is, they've given you the radius, and you're just trying to find out the angle. So you just need to rearrange your equation to work out what your missing angle is. Okay, 2 more for you to have a go at. Just pause me, do the questions, and then I will go through them with you. Okay, so this one is similar to what you've done before, except algebraic. So we don't know what anything is this time. So we've called P the full perimeter of your shape. You've got R for your radius, theta for your angle in radians. So your arc length is r theta, which gives you your arc from A to B. Then you've got 2 radiuses, so that gives you your formula for your perimeter, and it's just a matter of rearranging the equation to get r on its own. This one here, it's a matter of splitting up the triangle that you've got there, which is an isosceles triangle, into a right angle triangle, using your trig. But because you're trying to find out what the angle is in radians, you're going to need to make sure that your calculator's in radians when you do your inverse trig. You can then find out what the angle is in radians. Because we've split the complete angle there into 2 bits. We've worked out what half of the complete angle is. We're going to need to double that. If we take it from the number of radians in a full circle, so we're taking it from 2 pi. So we've worked out what that angle is there. We're taking it from the full angles in a circle, which is 2 pi, which gives us the remaining bit, which is theta. So from that, we can then work out r theta. So 2 times that. It just wanted the curved part of the arc in the circle. So we don't need to worry about the 2.4 along there. All we're doing is from A to B, going all the way round there. Here's an exam question for you to have a try at. Again, just pause me, give it a go. It used to be quite popular, this sort of exam question. So first off, your arc length from B to D, it's just part of the circle where you've got a radius of 8 and an angle of 0.7. So you're just using your arc length is equal to r theta. Now to get the perimeter of the shape. So we know that the length of the arc is 8. The extra bit there is going to be 3. Okay, we can use the cosine rule to work out what the length is from B to C along here, because you've got a triangle where you know 2 sides and the angle between the 2 sides. So the cosine rule will give you the length from B to C. And once you've got from B to C, you've worked out the arc length in part A, and we know that's the difference between the 11 and the 8. We can work out the complete perimeter of R. Okay, that's all. If you have a go at those questions, thank you.